Good morning, good afternoon, good evening. We are back and better than ever. We are talking about solving systems of equations. I'm calling it part one, even though we've discussed and investigated solving systems of equations by graphing. We are going to talk about solving them algebraically, so I'm calling it part one. Okay? And remember, a solution to a system of equations is the ordered pair or pairs that satisfy all equations, all of them in the system. A system of linear equations may have exactly one solution, no solution, or infinitely many solutions. So if I have a system of equations, okay, I'm just going to do three graphs, just a quick review here. Okay, if I'm going to have a system that has one solution, then it could look something like this, where the equations or the lines, the graphs of the equations intersect in one point, and that point right there is the solution. You could also have a system of equation that has no solutions, and that happens, let's see how well I can do this, when the lines don't intersect ever. When the lines are parallel, they don't intersect, there are no solutions. And then if you have two lines that are graphed and they are the exact same line, then, ooh, see how I did that? Not so bad. They are on top of each other. There are infinitely many solutions because there's an infinite number of places where they intersect. So now we're going to do all this algebraically, and the first method that we're going to use is the substitution method. Okay, so I have this system I need to solve. X plus y equals 4, 2x minus y equals -1, and they're cheating because they're telling us there's going to be a single solution. So with the substitution method, what you need to do is solve one equation for a variable. In other words, solve for x or y generally, because generally our equations are in the use x and y. Could be a and b or p and d, who knows? But usually x and y. So I have x plus y equals 4, and I'm going to go ahead and solve it for x. I could solve it for y, it doesn't matter. So to do that, I subtract y from both sides, and I get x equals 4 minus y. And now here comes the substitution part, because what I'm going to do is substitute into the equation 2x minus y equals -1. What do you mean by substitution? Well, these two x's are the same x's if it's a system of equation. They equal one another, which means they both equal 4 minus y, which means I can replace the x there with 4 minus y. So I'm going to rewrite this equation as 2 times, and I'm going to replace x with 4 minus y equals -1, and I'm going to move this party up here where I have some room. I'm going to distribute the 2, and I get 8 minus 2y, and I still have this minus y right here. Minus y is equal to -1. 8 minus 3y equals -1. If I subtract 8 from both sides, I get -3y equals -9, and then dividing both sides by -3, I get y equals +3. Cool beans. Okay, so I got to move over here. Sorry for all the moving around. I have y equals +3. How do I find x? Well, right here, I'll rewrite it, x equals 4 minus y. So now I'll use substitution again. Replace y with 3, and I get x equals 4 minus 3, or x equals 1. So the solution is the ordered pair, x equals 1, y equals 3. You can write it like that, or you can just write x equals 1, y equals 3. It doesn't really matter. We can check it easy enough. 1 plus 3 equals 4 using substitution. Let's see, 2 times 1 is 2, minus 3 does equal -1, so the solution does indeed Check. A couple of examples. What is it going to look like if I have no solution? Okay, so I'm going to solve this first one. I could use the second equation. I could solve for x or for y here, but if you look at that, I'm going to have to divide by 2. I might have some fractions involved and it might get a little ugly. So if I have a variable without a coefficient, that's the one I am always going to solve for. So x plus y equals 3. I could solve for y or for x. I'm going to go ahead and solve for x, and I'm going to subtract y from both sides. And I get x equals 3 minus y. And then I have my other equation, 2x plus 2y equals negative 4. So I'm going to replace this x right here with 3 minus y since the x's are equivalent. So I'm going to take 3 minus y and I'm going to substitute it for x, and I get 2 multiplied by 3 minus y plus 2y equals negative 4. So let's see what happens here. Distributive property, 6 minus 2y plus 2y equals negative 4. Well, let's see. Negative 2y plus 2y is 0. So I end up with 6 equals negative 4. Wait a second. 6 does not equal negative 4. 6 does not equal negative 4, right? So whenever you're using any of these methods and you get something that doesn't make sense, that's when you know you have no solutions, because 6 does not equal negative 4. So you are done. No solutions. Okay? You are done here once you get to an equation that doesn't make sense. Okay? The variables cancel out. I get 6 equals negative 4. Doesn't work. No solutions. Okay? And that would have happened even if I had solved for x. I'm sorry, solved for y instead of x. Okay, infinite number of solutions. What does that look like? Well, let's take a look. Well, this one, I don't have to solve for a variable because y is already solved for. So I can immediately replace y with negative 2x plus 3. Okay, negative 2x plus 3. So I'm going to have 2 times negative 2x plus 3 equals 6 minus 4x. Okay, so negative 4x plus 6 equals 6 minus 4x. And I wrote 3 here. That's confusing. 2 times 3 is 6. Okay. Wait a second, this is the exact same thing, right? I mean, if we continued on, like if I added 4x to both sides, plus 4x, right? Let's see, this gives me 0, this gives me 0, so I get 6 equals 6. So if you were able to eliminate your variable and you get an equation that does make sense, 6 equals 6, that's when you have an infinite number of solutions. So you would simply write infinite solutions. Okay. Now, why is that? Why are there an infinite number of solutions? Well, let's go back to this equation right here. Negative 4x plus 6 equals 6 minus 4x. Whatever value of x you replace, for whatever value you replace x with, you're going to get a true statement. For example, if I let x equal 0, 0 plus 6 equals 6 plus 0. X equals 1. Negative 4 plus 6 equals 2. 6 minus 4 equals 2. X equals 10. Negative 40 plus 6 is negative 34. And 6 minus 40 is negative 34. So that's why there's an infinite number of solutions. And then last example, let's just pick one randomly. Let's say number 14 will do. Okay. So that one already has y solved for. So I have x plus 2y equals 6, okay, and y is already solved for, so I am going to that's Pac-Man. See the little Pac-Man path? Fantastic. Okay, I'm going to replace y with 2x plus 3, so x plus 2 times 2x plus 3 is equal to 6. X plus 4x plus 6. Did I do that right? Yep. Equals 6. X plus x is 5x. 5x plus 6 equals 6. Minus 6. Oh, I'm glad we picked this one. Minus 6. And we have 5x equals 0. And a lot of times people freak out. What do you mean? You can't, how do you do this? Well, no, it's easy. Divide by 5, divide by 5, and x equals 0. 0 is a perfectly good number. 0 divided by 5 is 0. Now if it was 5 divided by 0, well, that is undefined, no solution. But it isn't. It's 0 divided by 5. We can't divide by 0. It's not possible. Okay, so we have x equals 0. Well, what does y equal? Well, remember, we have y equals 2x plus 3. So y equals 2 times x, which I know to be 0, plus 3. Well, 2 times 0 is 0, plus 3 is 3. Okay, so my solution is x equals 0, y equals 3, and there you go. We can check it out and make sure. Replacing x with 0, is 0 plus 2 times 3 equal to 6? It certainly is. And is y equal to 2 times 0 plus 3? Is 3 equal to, replacing y with 3, does 3 equal 2 times 0 plus 3? Certainly does. 2 times 0 is 0, plus 3 is 3. So we know we're right. All right, that is it, and I am out!